Okay. A very warm welcome to all the eminent speakers and participants to the webinar on system challenges and opportunities in electric vehicle integration with the grid, jointly being organized by Global Smart Energy Federation and International Smart Grid Action Network. Smart charging and B2G was introduced by University of Delaware in late 90s. It is a mandatory step to prevent simultaneous charging of numerous EVs. But much more can be done considering that EV batteries can also be seen as virtual distributed stationary storage. Renewable sources and electric vehicles will impact the power system at different scales. All distribution systems are not created equal, and this often poses challenges when comparing countries and urban cities. Even within the developed world, there are large variations in system strengths. This webinar will provide a platform to industry experts, academia, technical executives, experts from standardization bodies, power distribution companies, fleet operators, private developers to explore electric mobility better. Here's a quick look at the agenda of the webinar. We will be starting the webinar with the welcome address by Mr. Reggie Kumar Pillai, Chairman GSEF, and Mr. Luciano Martini, ex-co-chair ISGAN. Going further, we'll have two keynote addresses by Ms. Pauline Handroyd and Professor Magnus Olofsson. Then we will proceed with the panel discussion on the topic System Challenges and Opportunities in Electric Vehicle Integration with the Grid, which will be moderated by Mr. Ravi Sitapati. Joining the panel discussion, we have Mr. Magnus Brolin, Director, Electric Power Systems at Research Institutes of Sweden, Ms. Lonike D. Matters, Director, Standardization ILAD and Open Charge Alliance, Mr. Antonio Ilicito, Co-Chair of Working Group 1 on Grids and System, ETIPSNet, Mr. Mark McGranigan, EPRI Fellow and Vice President, Power Delivery and Utilization, EPRI, Mr. Makato Dev Yoshida, Secretary General Shadimo Association, Japan, Marc Petit, Professor, Central Supelec, France, Ki Jun Park, V2G Project Manager, KEPRI, Korea. Going ahead, we'll be announcing the themes for the 8th ISGAN Award of Excellence, and the closing remarks will be by Mr. Reggie Kumar Pillai and Mr. Luciano Martini. Now, I would like to invite Mr. Pillai for the welcome address. Reggie is the president of India Smart Grid Forum since its inception in 2011 and is also the chairman of Global Smart Energy Federation since November 2016. He is an internationally renowned expert with nearly 4 decades of experience in the electricity sector in diverse functions covering the entire value chain and across continents. Over to you, sir.
Good morning, good afternoon, good evening to all the participants and other distinguished speakers who are joining us for this webinar today. It really is an honor for Global Smart Energy Federation to partner with ISGAN and conduct periodic webinars on emerging topics of interest. The previous webinar we had conducted about 6 months ago. So this topic, in a short span of time, although the rebirth of electric vehicles happened about 10 years ago with Tesla, and even at that point in time, a battery, a kilowatt hour used to be $1,100 to $1,200 per kilowatt hour. That price today stands at $100 to $120 per kilowatt hour. In this decade, the past decade, the price of batteries has come down by 90%, which was actually set off a electric vehicle revolution. So in the beginning, when these people used to connect electric vehicle to our grid, we never bothered about it. It was an insignificant load. But today, with millions of electric vehicles, the fleet size has already touching 10 million around the world. This is without the two-wheelers and three-wheelers. And electric vehicle in a very short span of time has become an inseparable and a significant load on the grid, and grid need to manage, means you have to manage this load. And there is no certainty a particular electric vehicle will connect to the grid from where. Today, maybe from home, from office, it may be from any other public charging station point. So what load will be on my grid, distribution grid, and it is going to happen from where? I have no clue. I can't make any kind of proper estimation today with the existing systems. So charging stations need to be remotely monitored and controlled. That's the only way we can manage the load. But at the same time, large fleet of electric vehicles connected to the grid, we can aggregate them as distributed or virtual power plants, which can support the grid. The most interesting part is that the solar rooftop, which has become economically attractive to most categories of customers around the world, even without any government subsidy. 1 kilowatt of rooftop solar, including inverter, price is between $500 to $600, and the payback period is 2 to 3 years in most part of the world. So at that price and at that level, the scaling up of rooftop is quite possible if the distribution utilities are cooperative. If they cooperate, it can be a solar rooftop revolution. But as the share of solar rooftop increases on the distribution grid, the variation, the intermittency, on a day when you look at it, the solar power goes and comes down in the evening. You will see a daily curve as a smooth curve, but within 1 minute, within 5 minutes, you could see sharp differences. Those spikes, those dips, that can be mitigated because the electric vehicles and solar rooftops are both connected to the same low voltage grid. And today, V2G technologies can mitigate that. The batteries in the electric vehicle can smoothen the output of rooftop solar. That's a future, and those technologies are already maturing, and we should be able to see that happening and more importantly, in many geographies, there are surplus green power available during the day because of solar and wind generation. The green electrons which are generated during surplus hours during the day, that can be used to charge the battery, making it a complete clean and green transportation. So in every scenario of net zero transition, which we are talking about, and next week what is going to start in Glasgow at the COP26, the all vectors lead to decarbonization of the transport sector, which can be done successfully through electric vehicles charged from renewable energy, and that is something which is feasible, possible, for which we need to have new technologies. And this webinar, we have brought the best minds around the world to discuss about the emerging technologies and trends and systems that can be leveraged for green energy transition and green energy transportation. Thank you very much. I request my co-host, Mr. Luciano, to say the opening remarks.
Thank you, Mr. Pillai, for the welcome address. Now I'd like to invite Mr. Luciano Martini for the welcome address. Luciano Martini has more than 25 years of experience in research and development and international cooperation dealing with renewable energies, superconductivity, and smart grids. He is the director of the Transmission and Distribution Technologies Department at RSE and the EERA Joint Program on Smart Grids Coordinator. Over to you, sir.
Thank you very much, Ashima. Thank you very much, Reggie, for your kind words. I would like to welcome all participants to this webinar from the ISGAN side. I'm the chair of ISGAN, and I'm very glad to be co-organizing together with GSEF this important webinar. I would like to mention that we have a long track record of collaboration with GSEF on several topics, and we both, ISGAN and GSEF, value the importance of international collaboration, especially when addressing important and difficult challenges that are related to the energy system transformation. And since there is a need to address the challenges properly, there is a need to involve all relevant stakeholders in order to find a viable solution that can be implemented in the real life. International collaboration is key. Electric vehicle and the electrification of transport sector is also very important, not only for our society, but also for the energy and the power system. In this case, I would like to clearly state that for ISGAN, electrification of transport is an extremely important topic because it represents really a big opportunity for the evolution of our system. It's also a good opportunity to strongly reduce all emissions related to the transport sector. And on top of that, it could be the real first important and immediate impact on what we call system integration, because electric vehicle will be connected to the system through the charging infrastructure. And so we are, of course, looking to smart charging solution and also to more advanced functionality as a vehicle to grid, and so the vehicle supporting the grid in certain part of the day on some contingency. So it's important to say that we as ISGAN strongly supported this webinar, strongly support study and research and innovation on electric vehicle in order to inform a policymaker around about the right approach to be used for this important topic. As an example, ISGAN has been fully involved in what is called horizontal accelerator for EV integration in power system. Was an important initiative launched within SEM, Clean Energy Ministerial, that was involving 4 different work streams, and ISGAN were really fully engaged, and Magnus, in his keynote, in his presentation, will duly report about this important activity from ISGAN. On top of that, it's clear that ISGAN rate very important this topic, because the ISGAN award theme for this year is exactly based on electric vehicle. At least one of the 2 awards is based on electric vehicle. These are clear indication that we want to push forward this topic and address it properly. I think today we have a very nice program for our webinar, very distinguished speaker, and I really hope that all of you will enjoy this webinar and found it fruitful. And please stay with us and contact us even after the webinar in case you have some detailed information to be collected. Thank you so much. Back to you, Ashima, and please proceed with this webinar. Thank you.
Thank you very much, Mr. Luciano. Now we will start our webinar with the keynote addresses. I would request Ms. Pauline Hendroit for the keynote address on global EV deployment policy scenario. Ms. Hendroit is the Energy Policy Analyst at International Energy Agency. She is working in the Energy Efficiency Division. She works on the 310 project on consumer flexibility and network digitalization. Over to you, ma'am.
Thanks. So I will be sharing slides. So now you should be seeing my slides in presenter mode. Except if I do that, I can't see my speaking notes. Well, that's a problem I had not expected. Here you do not see them right, like if I put them like that.
Ashima, can you, sorry for the interruption. Ashima, you can project the slides, and Pauline, you can say what next slide. On your screen, you can look at the speaking notes. We will change the slide. We will project and we will change the slides.
Yeah, I will do
Is it
that.
okay?
Give me a moment.
Okay, thanks. Sorry for that.
You can stop sharing.
Yes, thanks a lot, and sorry for the technical glitch. So for this keynote speech, I'd like to take a broader view on EV deployment scenarios, because all the questions we're going to address of EV integration in the power system comes from a broader context of very quick EV development. So as you see on the slide, click please. Perhaps we can go without the animations because it will be so you can click twice on this slide. As you will see on this slide, there is the EV experienced a period of fast growth in the last 10 years. The slide does not seem to move. There should be figures on the graph.
Go back to the first slide.
Sorry, no, sorry. Well, I will share a slide and manage without speaking notes. Very, very sorry.
You can just press enter only, enter, not the slide. Just enter here. It should. Ashima, just press enter on your slide.
Sorry?
Exactly. That's it. We can see now.
Great. No, so now you should be seeing my slide. So
Yes, we
as
can.
yeah. So as you see, in the last 10 years, the electric vehicle stock increased very quickly, and there were fear amid COVID that electric vehicle would stop growing. But while almost all the economy was in difficulty due to lockdown, electric vehicle continues increasing and increased 40% year on year, meaning that now we have an electric vehicle stock of about 10 million. Looking at it, as you see it in the slide, it seems a dramatic increase, but as you might expect, it's far from what we need to close the gap to a net zero scenario. So in this presentation, I will be referring to the classical world energy outlook scenarios from the IEA. So the one that is named APS for announced pledge is the scenario that happens if all states meet the pledge they announced, and net zero and ZDE is obviously the scenario that brings us to net zero by 2050. Looking just at CO2 emission in road, the APS scenario is 2.6 gigaton under the stated policy scenario, which is already a big win. But what we see is that to meet this scenario, we're not talking anymore of a stock of 10 million vehicles, where 100 and close to 1,000 million vehicles needed. And that is only for the announced pledge scenario. If we want to meet net zero, the effort is even bigger. From IEA research, most of the development of electric vehicle is cost competitive, by which we mean for the user in the full cost of the vehicle. It is, for now, it is not in every region in the world. It is in some cost competitive in some region in the world, which are the one where fuel is the most expensive. But it could become, but still, if we want to meet net zero, it is not fully cost competitive in every situation. And also, and that's what you see in blue, and we'll come back to that later, it is not just about cost, making sure that people adopt electric vehicle. There are other measures that are not cost, but that can help by bringing a suitable environment for electric vehicle. We'll come to that later, but I would like just to notice it already. And before, most of my presentation will be on electric vehicle, but I would like to point out that decarbonizing transport is not just about decarbonizing electric vehicle. There are many sorts of transport, and not all of them will decarbonize at the same rhythm. We see that light-duty vehicles are the one that emit the most CO2 currently, but also the one that it will reduce the quickest. Other will take more time before starting reducing the emission, and that is mainly due to the technology we need to that. Because when we are talking about light-duty vehicle, it's mainly technology that we already knew, they are already ready for the market. It's more about deploying. When we look at heavy truck or shipping or aviation, we see that it's more mature, there are less mature technology, or even the technologies that are still at prototype. So that explains why light-duty vehicle will bear the bulk of the reduction of CO2 emission reduction from transport in the coming years, with the other transport mode reducing more after 2030. So let's look more broadly at the scenario for this, for achieving this net zero, from this net zero scenario that the IEA wish we could meet. So transport won't be fully net zero by 2050. It's one of the sectors that still is not a net zero emitter, but it reduces dramatically still, with a few milestones that must be met. For instance, by 2030, to meet net zero, electric cars should represent 60% of sales, and by that time they should also represent 20% of the stock. And by 2035, there should be no more sale of new internal combustion engine car sales. And there are many other milestones, and that is how we might be able to meet this net zero for the global for the global warming. What I'd like to point out here is that for now, some countries have already announced pledges that are in line with this milestone, especially the one about no new international combustion engine car sales by 2035, but not all of them yet. And it's not just about announcing pledges. Now we'll have to see if this milestone can truly be reached. But as I said, it is not just about meeting. It is to meet these targets. We will need to have more than just pledge. We need policies, and we need to help by building a suitable environment for cars. There are many other aspects that just cost that will help or not help electric vehicle deploy. One of the main topic is charging and fast charging. Again, we see a very strong trend in increasing of a fast and slow accessible charger for electric light-duty vehicle. But again, given the trends we want to see in EV deployment, we need this trend of available charger to also accelerate. And that is only one of the favorable policies that could favor electric vehicle adoption. There will be other questions on how, for instance, a second-hand market will work, because that's really important, especially in less developed economies. So there will be a lot of policies needed to put a favorable environment that will help develop and meet this milestone that we need to meet if we want to reach net zero by 2050. And last point, which is one that I expect to be much discussed today, it's not just about being able to charge vehicle, it's also about being able to charge them at the right time. Here we see the peak capacity of various countries. And here we see that with renewable increasing their share in peak, we have less dispatchable peak capacity. But by increasing V2G potential, we could be able to meet part of the flexibility needed and reduce peak, so that's to be better able to incorporate renewable. So that is a subject I hope to see discussed much during the panel discussion. It's a topic of very high importance, because if we cannot use a vehicle to get charging to reduce peak capacity and increase and charge them more at off-peak, it will be really difficult to integrate them and reach this milestone that you have seen are really high. So now I'm looking forward to this discussion and better understanding on how you would see this ability of electric vehicle to integrate into the power system. Thanks a lot for your attention.
Thank you, Pauline, for sharing insights on global EV deployment policies scenario. Thank you very much. Now, may I request Mr. Magnus Olofsson to present on the key insights and policy messages from Horizontal Accelerator on EV power sector integration. Magnus Olofsson is a Swedish national expert and knowledge transfer platform lead, ISGAN. He holds a PhD in Power Systems Engineering from Royal Institute of Technology, Stockholm, Sweden, and has founded Swedish Energy Institute. He is an elected fellow at the Royal Swedish Academy of Engineering and Sciences. Over to you, Magnus.
Okay, thank you for that introduction. I hope you see my slides here, or my initial slides.
Yes, we can see. We can see it,
Thank you.
Magnus.
That's great. That's great. I will make a summary here of a work we did last year, and I give here the overview of this already mentioned SEM horizontal accelerator project. Unfortunately, I can't activate my camera, but you hear me well, I hope. The project theme was electric vehicle and power system nexus, how to support large-scale adoption and effective integration. That was the key question. We presented results from this work at the SEM 11 Mission Innovation 5 meeting in Saudi Arabia, but it was over the web in September last year, and the results came from quite a comprehensive work by 75 international experts from 17 countries. And the peak of the work was a 2-day virtual workshop held in the spring last year. And we had experts from various sectors, I mean, both from the kind of power system sector as well as from the transport sector, and then also from policy making organizations, as well as research and international organizations. I can also mention that we used a digital collaboration platform in the view of COVID. We couldn't meet physically, but we operated or collaborated more on a digital way, in a new way. And it's also important to emphasize that we work together for SEM work streams, and it's on the next slide. See if I can get it. This is first the picture from the report at the SEM 11 meeting. And here is the picture showing the 4 work streams working together with a little different focus of the whole picture here. Power systems planning and operation, integration issue storage, 21st century power partnership, EV initiative, EV technology, charging, EV market perspective, and then ISGAN, smart systems and ICT, TSO, DSO perspective, regulatory aspects and market design, and power system flexibility campaign, power system flexibility. Of course, EV as a flexibility source, not the least important. I would also like to mention that we had the honor to have Elina Levina at the SEM Secretariat to be the overall project manager and steward in this work, keeping us all together and aligned, working in the same direction. So the focus was EV power system integration. And here's the report, and the link is to the very left. It's hard to read, but you can Google it and find it on the web. Electric vehicle and power system integration, key insights and policy messages from 4 SEM work streams. And there you can read about our findings. And here are our findings, very, very quick. A to E, vehicle electrification is a critical building block in the ongoing energy transition. That was well underlined by Pauline here before me. It's very clear that going forward in the energy transition, we need to go electrical with the road transport. And we actually, maybe I should mention that we have like 2- and 3-wheelers, we have cars, we have vans, we have trucks and buses. So it's the whole concept of road transport we covered, not only like regular cars. Maximizing the benefits of transport electrification requires the active engagement of diverse stakeholders. So it's all the way from municipal planners to power grid companies or distribution companies. Mechanisms to integrate EVs need to be designed with regard to EV users and their mobility needs, as well as the optimal use of grid assets. It's easy for me, like being a power systems engineer, believing that the main focus for an EV is to be a flexible source, but that might not be the case for a regular EV user, non-electrical engineer EV user. I'm joking a little, but it's important to know that mobility is found to be kind of the main reason for or main focus for many users. D is the infrastructure planning is central to support vehicle electrification. And that's not only the grid, but of course the grid is very important, the capacity of the grid. It's also having space for the charging infrastructure, for example, and not only for, I mean, what we normally call cars, but also for heavy vehicles, at depots, at resting places and so on along the highways. Finally, successful EV integration will require a diverse array of technological solutions and potentially changes to regulations and market design, not the least to cover the flexibility ability of the EVs, mainly cars. Yeah. I go maybe a little deeper here, but I can't really go very, very deep. But this is the first, again, then, A, vehicle electrification is a critical building block in the ongoing energy transition. We know that the transport accounts for approximately a quarter of energy sector greenhouse gas emissions. In addition, we have particles and other emissions that we get from combustion vehicles. Transport electrification is only one aspect of the broader transformation, and it enables integration between transport and power systems. We can actually use the EVs, for example, as a flexible user of electricity and flexible user of grid capacity, not the least, especially in the local grids. Coordinated action can produce beneficial synergies with electrification in other sectors and power system transformations to benefit users and support decarbonization. We are seeing more variable renewable sources, solar and wind, to be precise, and we here have an opportunity to use charging in a clever way to kind of balance the system. Clean transport solutions must consider new mobility options and account for behavioral changes when planning for future urban design and power system. It's maybe not just to replace a combustion car with an EV car. It might be also a good idea to look into digitalization and automation in that respect. We have the sharing economy potentially coming. Self-driving cars, it can go actually in various directions here, but it's important to consider all these other aspects also. B, then, maximizing the benefits of transport electrification requires the active engagement of diverse stakeholders. Very true. Already said, it's urban planning important and power system transformation also equally important in this context. Providing users with relevant and high quality information about charging options and associated costs is key. It's important to be able to make the right choices, I mean informed decisions by users. Open protocols and international standards are needed to ensure compatibility of charging infrastructure in EVs, and that's all the way from the kind of the hardware, where current and voltage and so on, but it's also the digital part of the infrastructure. Yeah, and C, mechanisms to integrate EVs and the power system need to be designed with regard to EV users and their mobility needs, as well as the optimal use of grid assets. Essential to understand the diversity of mobility needs and transport modes to design effective electrification solutions for different applications. It's very true. And as I already said, flexibility in EV charging will be secondary to mobility needs. Mobility needs will be maybe unfortunately being power system oriented, but that's true. So we need to keep that in mind. And sometimes users might be very willing to pay extra actually for putting mobility needs before the power system need. But not always. Effective incentives need to be designed and implemented to compensate users for providing flexibility. Yeah, that's true. They have to be somehow remunerated in that respect. Regulators can facilitate this by redesigning tariffs and cost recovery mechanisms, enabling electricity providers or aggregators to simplify the active participation of final users. Yes, regulators and policymakers are important here. D, infrastructure planning is central to supporting vehicle electrification. That's very true. We see that, especially in cities for cars, it's kind of a challenge to get access to charging now when EVs are actually rolling out in a very fast or actually accelerating pace. So home charging as well as workplace and publicly accessible charging. Well-designed charging infrastructure and power system integration can support decarbonization and lower costs, both for EV owners and electricity users in general. Yes, it's important to make this designed in a proper way. Different pathways for rolling out charging infrastructure affect the mobility options available to users and the ability to engage with the grid. So how will we prepare for the ability to engage with the grid in the infrastructure planning? That's also an important perspective of EV power system integration. We know that, which is obvious, that vehicle charging may represent a substantial increase in electricity demand. What we know is that normally the bulk power systems, both from a generation and transmission perspective, is not a problem. It's mainly the local distribution system that is actually feeling the capacity going up, or capacity need going up, I can say. But we also know that EV charging flexibility then is creating strong opportunities to mitigate potential impacts on both bulks, but mainly on distribution systems that could reduce the total electricity cost, avoiding investments. So it's about where to localize charging infrastructure and also how to make the incentive programs to compensate users for providing flexibility to be part of the reduction of investments in the grids and in the distribution networks. So we have a lot of different tools here, and we have many stakeholders that should collaborate in order to make this working. And regulations and market design are then naturally very important. I think that was maybe the whole story from my side. I hope I didn't make it too fast, but if you want to have more details, please read the report, and you're most welcome sending any questions to me, or maybe potentially ask them now. I don't know if I have time for that. But thank you very much.
Thank you, Magnus, for the keynote address. Thank you. I would request the audience to keep posting their questions in the chat box during the session. We'll be compiling the questions for the panelists, and we'll be sharing the same in the end of the session during the question and answer round. We are now about to begin with a panel discussion. Joining the panel, we have, this is a quick glimpse of our eminent panelists. Joining the panel, we have Mr. Ravi Sitapati. He is the Executive Chairman of Bioceres Incorporation Canada and Corporate Director on the board of Larsen & Toubro's Power Transmission and Distribution Division India. He also serves as the Ambassador for the Americas for the Global Smart Energy Federation USA and as an advisor to the India Smart Grid Forum and India Energy Storage Alliance. Mr. Ravi Sitapati will be moderating the session. Next, we have Mr. Magnus Brolin. He is the Director for the Electric Power System at Researchers Institute of Sweden. He has for the last 2 decades led and been involved in research and innovation projects regarding electric power systems and markets. Dr. Brolin is a technical lead in ISGAN Annex 6 on transmission and distribution systems. Then we have Ms. Lonike Drissen-Mutters, Director Standardization and Test Lab at ILAD. She is responsible for the EV charging testing facilities, open standards development in secure EV charging, and is in charge of activities regarding the Open Charge Alliance and eClearing.net. Next, we have Antonio Ilicito. He is the co-chair Working Group 1 on the Grids and Systems. ETIPSNet is an active member in ISGAN Annex 6 on transmission and distribution systems. He is also the convener of Working Group Future Energy Systems in ENSO. We have Mark McGranigan, Fellow at the Electric Power Research Institute. Mark coordinates with research sectors at EPRI as well as technology innovation function. Mr. Makato Dev Yoshita, Secretary General Shadimo Association, Japan, is a mechanical engineer by training and have been involved in electric vehicles over a decade. Mr. Makato brings to table his expertise in zero emission vehicle technology and vehicle safety, specially dedicated to ZEV safety, as well as technical standardization and legislation fields. Next, we have Marc Petit, who is a professor in Centrale Supélec and Gibbs Lab, France. His research is dedicated to electric power systems. He is also the Armand Peugeot Chair, dedicated to the economy of electromobility. Mr. Ki Jun Park is the head of the Energy Solutions Group, Smart Distribution Laboratory, Korea Electric Power Research Institute. He was involved in commercial grade VGI V2G development and demonstration of the wireless power transfer EV charging, GIS substation PD diagnostics, and preventive maintenance PD sensors. Now I would request Mr. Ravi Sitapati to start the session. Over to you, sir.
Thank you, Ashima. Thank you to all the speakers before us. It's good to see all our fellow colleagues over the years. Sorry for the COVID disruption, but hopefully we will see face to face again. We've had two great speakers. I think one, which is formally led by the IEA, we look to the IEA for the top-down approach, which says, where should we be strategically to achieve a collective objective? And that was done very well by Pauline. And then we also had a bottoms-up view, which said, what would be the user's issue or the user's view of looking at electric mobility, and also from a power systems perspective. And so we had Magnus provide that. So there were several pockets of queries raised in their talk. Very fortunate to have our panel today constituted from experts around the world, almost from one end of the Pacific to the other end of the Pacific, if you can cross right through the European Union. So very fortunate to have this group here to answer some of the questions and to share their thoughts. The way this panel is going to work is many of us, not me, but the speakers, would have 5 minutes to present a thought of theirs. And then at the end, after everybody is finished, we will have a general Q&A. So the speakers have already been told to limit their presentations to 5 minutes, please. And then so that we can have some amount of time for the Q&A in the panel as well as the audience question, which seems to be filling up. So we will go by the order of the speakers in the agenda. So I'm going to request now Magnus Brolin to start with his presentation. Thank you. Magnus.
Thank you so much for the introduction. I will now share my presentation. I hope that you can see my slide in full screen now. Maybe somebody could confirm that you see it?
Yes, we can see it, Magnus.
Perfect. Thank you so much. So I thought that, as Pauline and pointed out before, that the number of EVs has increased a lot and will continue to increase in the future. That will have, of course, a huge impact on electric power system, but also creating maybe new technical potential to support electric power systems with different smart charging and vehicle grid solutions. Now, the focus of today's discussions is on the system side, but I might go into a little bit more into the EV owners' interests and so on, and their willingness to participate in these kind of flexibility schemes. It's a complex system, and there are multiple factors that have an impact on this potential. And I think that the presentation from Magnus Olsson before gave a very good overview of all the different aspects that can be considered, need to be considered in this complex landscape. Looking into the different drivers for electrification and flexibility and so on, it has been pointed out the users, owners of EVs, the main driver is the transportation needs. That is why you purchase or invest in an EV or other kind of transportation service. There are numerous factors influencing the need and to assess the impact of the transportation on the electric power system. But starting with different kind of, for example, start times or different kind of transportation needs, together with the length or duration of different transportations, is parameters that needs to be assessed in order to understand the charging patterns and to understand the impact on the electric power system in the end. It's important to understand this is the primary interest of the EV owners, while providing flexibility to the electric power system, either being through acting on the wholesale market to balance price variations or to provide system services, are very much secondary in this respect. It's more of an added value rather than being in the center of the electrification. If considering market-based flexibility and EV users, I would like to highlight some thoughts or reflections regarding that. The first one is that since the value of the perceived value of the EV users for the transportation service is quite high, and the expectations in terms of reimbursement cost reduction levels on the electricity side for providing system services or acting on the general market in a flexible way are much lower in comparison. And that can create like a discrepancy between the idea of the willingness for the participants or the EV users to participate in the flexibility market or on the wholesale market on the electricity side. There are also transactions costs to take that decision for EV users to be able to. There are thresholds levels that needs to be overcome to be able to enter the market. It's not only cost themselves, but also before you get their correct or you get enough incentives to actually act on the market. So this creates some opportunities and some challenges, very much related to creating attractive offers from service providers and aggregators that could provide the service of bringing the flexibility of the EV charging or vehicle to grid solutions to the grid and to the market, and still meet requirements and expectations from EV users. And here I think that one of the discussion points can be what share of participation can be expected if you go the market approach of EV users. There are different kind of experiences about that from different pilots and tests around the world, and I think that the results are quite diverse in terms of what has been expected or what has been achieved in those different pilots. It's certainly an uncertainty that needs to be taken into account when planning and when planning for integration of EVs into the electric power system. Just to summarize things, so there are research and there are demonstration pilots, and they are indicating a lot of or big technical potential for smart charging and vehicle to grid solution to support electricity grids around the world. But in order to fully understand the true opportunity and challenges on system levels, for example, for TSOs or for DSOs or the market itself, I think that the understanding of market participation of EV users and their willingness to participate at threshold levels, etc., needs to be more knowledge around that to get this true potential correct. Thank you for your attention.
Thank you, Magnus. I'm now going to invite Ms. Lonneke Dreisen-Mutters to the podium, please.
Thank you, Ravi. I'll now share my screen. So can you see now in full screen mode? Okay. So welcome everybody. I'm very happy to be the second speaker on this panel. And my name is Lonneke Dreisen-Mutters, and I work for a Dutch organization called ELAT-NL, which is a non-profit knowledge and innovation center in the field of smart charging infrastructure. And we were founded in 2009 by the Dutch electricity grid operators because we wanted to learn more about the impact the electrification of transportation would have on our electricity grids. As Pauline mentioned in the introduction, the target is that in 2030, 60% of all vehicles will be electrical. And in the Netherlands, at least this year, we have seen a percentage of new car sales of 20%. And if you look at only last month, the sales of electric cars was 33%. So 1 in 3 cars that were sold last month in the Netherlands were already electric. So we are well on our way to electrification of transportation, and that's good news. So ELAT.NL was founded more than 10 years ago, and to mark our 10th year anniversary, we published a smart charging guide back in 2020. And the reason for that was we wanted to inspire and inform not only experts in EV charging, but also to a lot of parties that are new to this topic. As this market is growing, of course, more and more people are becoming aware of this development. And we found it a good idea to share what we've learned over the past decade in the form of this guide. You can download it from our website and read through it if you like. The conclusion of this guide consists of a 10-point to-do list. So what are the 10 things we think are important to do to make smart charging a success? And of course, the time today in this panel discussion is too short to go through all 10 points. So I will focus on only one specific one. And I know that the speakers who are next in this panel will address many of the other points that we also identified in this smart charging guide. So no need to go over them at this moment in this presentation. The one point I would like to focus on, which is close to our hearts, is testing. So, of course, it stands to reason that when we are setting up a new system, regarding electric vehicle charging, you want to do a lot of testing, but this does not only concern safety testing or reliability testing, but a big part of this industry is about information technology, the exchange of information. And as you may know, if you have ever been involved in IT has a lot of bugs in it that you need to find and fix. And this EV charging industry is no different. Also, what is important to realize is that in this system that we are building together, it's not just one company, one party, one system, but there are multiple systems connecting multiple industries, and they are developing over time and also adding new features and new functionalities. Vehicle to grid is one of them, security certificates is another of them. So there are a lot of points where in this multi-actor system, there could be bugs that cause the system not to work properly. If you look at testing, what is first of all important to test for interoperability? So if I have a vehicle from one vendor, can it work on a charging station by another vendor that's operated by a network operator and connected to other systems? What is really important for grid operators is to test for power quality. As you know, our electricity grids are AC based, alternating current, and batteries are DC. So at some point in the EV charging system, you need to convert from AC to DC power using rectifiers, and this causes power quality disturbances. And we've seen this in many other industries before, and we are seeing this in the EV charging industry again, that not in all cases either the DC charging station or the electric vehicle itself is sensitive to power quality in general. So it's really important to test for that and to also educate those parties that they should address their power quality because we don't want them to disturb other users of the electricity grid. Smart charging, which is a big topic of this panel, is of course really important to test because it's important, for instance, that vehicles understand what's happening. And we've seen in the field that sometimes when you reduce the charging power, vehicles sort of fall asleep. And once you start charging at full power again, the vehicle no longer responds. And this is, of course, a big issue for consumers because we don't want unhappy consumers, EV drivers. So that's also important to test. Vehicle to grid, I mentioned this again. It's a very new development, at least for what we know. This, of course, is also it requires a lot of information exchange in a standardized way. And the last part, I think, what is really important to focus on is the information security. Not only that there are information security requirements in place, but also that you test if they've been implemented correctly. So this testing is, of course, done by individual companies, which is very good. So here you see two pictures of test labs. The left one is from ABB, and to the right you see ChargePoint. So they both spend a lot of time and resources on testing their own systems and making sure that, as far as they know, their systems are working properly in itself, following standards. But of course, they need to work with other components, other OEMs and other systems. So that is why the next step, besides individual testing, is interoperability testing between different parties. So on this slide, you see two pictures of two industry initiatives where vendors from across the world come together and test their implementations and see if they work very well together. To the left, you see the OCBB Plugfest to test the charging infrastructure with the back office systems. And to the right, you see, for instance, a Charin Festival where charging stations and electric vehicles do their interoperability testing. So that's really good. There are really nice events, and really important that as many companies participate as possible. Of course, the final stage, and this is not always in place, would be in a more mature market to have conformance testing, certification testing, and big parts of the EV charging ecosystem are already there. And here you see a long list of, traditional test facilities, test labs that can do conformance and certification testing. But it's important to note that in this industry, there is still so much development that not all technologies and use cases are at this level yet. So you can rely on a certificate and you know that it will work seamlessly together. We still have a lot of work to do. But it's good to see that some parts are already quite stable and certification testing is already in place. That was the point I wanted to highlight, and I'd like to hand over to the next speaker in this panel. Thank you.
Thank you, Lonneke. So Antonio, the next 5 minutes is yours.
Thank you. And I hope you can see the usual question, the full screen. Now should be in full screen. Thank you for inviting me here. I will bring a European grid and system operator view on this subject. The title wouldn't be more fitting what we are just after. We are also going to publish a position paper exactly on the best integration between electric vehicles and the grid. So some of the things I will show, and so I will not maybe talk about them, have already been addressed by very distinguished speakers before. We know the electric vehicles are there since long time, and now they will become mainstream. We have seen the projection by IEA, and how to integrate them. The physical interface is the charging point, which is not like for gasoline, only a fueling station. Actually, it's part of the system. So the charging point is actually charging infrastructure. And here we see we will have, I would say, at least 3 revolutions in one go. First of all, the electric engine is intrinsically more efficient than the internal combustion one, is more clean, easily to maintain. And then it will come with the decarbonization potentialities as long as renewables will develop on the same pace. And also, they will be connected not only for electricity, but for information data. So a whole artificial intelligence, digitalization will come there together. So it's very important to start with the right fit, with the right technologies and right standards and operation. And particularly here, as you see these 2 circles, we are interested, we are focusing on slow charging instead of fast charging. And this is not just, it's important to emphasize, because a lot of resources also on the innovation is put on fast charging, but we will need the slow charging for having also the benefits, extra benefit that we can have from flexibility. As it has already been said, there is a consensus also from our side that even the full shift to electric vehicles, all categories, will not determine an energy deficit issue, but it can be a peak power issue. And this can be more important for local level, for distribution grids, but then for TSOs, also we have to ensure that there is no problems for the contemporaneity of the charging, because if we left alone the typical users would charge, as we have seen also from French studies on the behavior, because behavioral drivers is very important on the evening and in the night. But if we go to smart charging in the bottom left, or the vehicle one grid, we see that we can shift the power request at suitable times. But then another big step is the vehicle to grid bidirectional, because we can extend this reshaping of load power load profile effect to the entire residual load. So the curve, which is the blue one without any incentive, can become the orange one, and even the gray one, which means having a flexibility which is going more deep than the actual need of the total charge, because you can use also this as a battery. So it is a leverage effect. So this flexibility means is more valuable than other flexibility means. So we studied a sort of taxonomy from this point of view, and we see that concentrating on slow charging, there is a paradigm shift. Instead of fueling on the move, which will be still there for highways, but we can some studies say 80-90% of the refueling of electric vehicles will be in more static. So it means that we will fuel our car, we will charge them when they are parking. So not when they move, but when they do not move, which leaves a huge opportunities and a different charging solution for different use cases. So the driver need will be paramount. And we have to attract him not only with price signals, but with a really comfortable experience, because maybe the price signal is not enough compared to the other costs of the total mobility cost. So, for example, this is one classification taxonomy we have done. We have on the top right, the stopover charging, which is similar to the present one, and we will need this for long trips. But then for the vehicles which will be charged while parking, we have different categories. For example, company fleets like bus depots, they have a very predictable charging, probably mainly by night, so they are fit to provide some services. And even more, the ones which are in green color here, which are normally idle between 80 and 95% of the time, they clearly can be used as batteries on wheel. And we think all these use cases will be developed, and we have to extract the most benefit from all of this. This is a summary of the different benefits which can be stacked one on the other, starting from this top one, reshaping the power load curve. This can help managing grid congestion, especially at the local level, so distribution grids, and so avoiding overloads. And also they can help control the voltage there. So if they are integrated in the planning, so the grids can save new reinforcements and also operational advantages. At the same time, the system will benefit from reducing curtailment and overgeneration in general by renewables. And if we think at customer service, which is consumer, but now is also a producer and also have some storage, instead of having a static storage, you can have the battery of this car optimized. So optimizing the behind the meter services is another benefit. And then we have also to carefully plan a hypercharger, because we will need large capacity and fast speed. One point, it has already been tackled. This is really an ecosystem. It's very wide. There are many actors. They are very different. So there are many kinds of interactions: energy interaction, commercial interaction, data and ITC interaction. And some of these actors, like urban planners, transport, but even the building sector. Now we with this renovation way of the building, all the buildings which do not, which are not now suitable for electric vehicle charging need to become. So all these are different sectors with different logic and not used to be integrated with others. So we cannot see this only from the electric system point of view, and we have to find a good way to integrate all the different needs. In any case, the consumer will be in the center. If we follow this arrow, the user behavior is the one which has to be studied. And let's remember that every car driver and car owner is also an electricity consumer. So we have to tackle both aspects together. What are the needs? What are the expectations? Not only of price, we said, but also quality. What extra services and new and extra services we can give. For example, if the time, even fast charger maybe require 10, 20, 30 minutes, we can offer to the driver other services in this time period, not only for long trucks, long driver trucks, but also for normal car drivers. And in the end, the user perspective has to remain pivotal, because we cannot make mandatory to have this smart charging. They have to accept it and look for it. So as a key takeaways, sorry to go fast, but we've given very few minutes, I would say some of this, which were also mostly the same of the previous speaker, Magnus. First of all, we have to understand it will be an ecosystem, very articulated. So the consumer and the centers, grid operators, we have clearly in mind what is our role, but we have to liaise with all the others with different logic, with different needs, different decision-making processes. So it is important to have a planning of this infrastructure for charging together with the electric grid. So integrated planning, which is now not the case, because we normally receive connection requests and we try to plan at the best the reinforcement of the grids. But if we have a larger view and a longer horizon integrated planning, this will be to the benefit of all the users, because then the tariff of the grid will remain as low as possible. So it is important not to go through retrofitting in the future. So now that we are at start of the exponential curve, we have to start now of every charging to be smart, and where this is convenient, technically and economically feasible, also vehicle to grid. Cannot be mandated by law, so we have to find technical standards and technical incentive to really deploy this win-win solution, avoiding to have to retrofit in the future. And as enablers, there are standards, interoperability, a lot about data management and digital service. This will be a revolution which is never underestimated. It can be underestimated, but it is very important, because we will not give only energy. We will give a lot of information. Where is the next charger? How much queue and waiting time is there? Not only what's the price, like we see now in highways for normal fuels, but a lot more information, traffic information, and many more. And then we will need the market design, which has to be updated, and possibly the tariff should be cost reflective, also fair for the infrastructure and the grid constraint. This is our main task, to avoid the congestion, which then are paid with ancillary services, which are costly to the user. And I think this is my last. Thank you.
Thank you, Antonio, for that detailed overview, following up on Magnus's presentation as well. So the next speaker here will be Mark McGranahan. Mark, the next 5 minutes is yours.
Ravi, can everyone hear me okay? A little sound check. Okay, good. I'm going to leave my video off. I'm a little bit challenged in terms of bandwidth today, so I use my bandwidth to share my presentation. Let me see if I can make it full screen here for everyone. How's that?
It's okay now.
Okay, good. All right. Following on Antonio, I think made all the major points, and I'm just going to try to make three what I consider to be very important points related to all of these use cases for integrating electric vehicle charging with the planning and operation of the grid in order to provide these services. And the first one is kind of the need for platforms to support this integration and coordination of the work going around the world in that space. The second point I'm going to make is related to resiliency. I think resiliency is in many cases a very important use case and value proposition that can go along with many of the other ones that we talked about, of managing demand and being a non-wires alternative for grid expansion to support electric vehicles. And related to the resiliency objective or value proposition is the role of energy storage in addition to the energy storage in the car itself. So I'll mention those three things just to start off and see where they fit in. But as we've heard from Antonio and others, there's many important concepts associated with the integration of electric transportation, the charging infrastructure itself, the integration of that charging infrastructure with the operation of the grid, and the management of that charging infrastructure, and the ability to go all the way to vehicle to grid in some cases. And cutting across all of that is the role of the customer and the building and the business case and regulatory considerations to make that possible. Spot here. All right. So platforms, there's work going on so many places around the world in terms of how we're going to integrate electric vehicle charging with the operation of the grid. I'll just mention this one that we're working on in California, and we're trying to make the platform itself open source, called the Open Vehicle to Grid Integration Platform. It's a joint effort of many of the electric vehicle manufacturers, the utilities, and the use cases that define the information transfer requirements that will be required in order to accomplish these use cases. So that's one to keep an eye on for everyone, and that fits into a broader concept of an open demand response integration platform. So vehicle to grid and vehicle charging management is one system under a broader integration of demand side resources, whether it's customer sited energy storage or smart appliances or building management systems, that becomes part of a broader infrastructure that we need to coordinate around the world. I'll mention one project from Europe that I think is particularly important, has a participation of utilities and a broad range of stakeholders, both TSOs and DSOs on the utility side, and stakeholders that would integrate things like electric vehicle charging, but really all of the consumer/prosumer type of resources. And the concept, similar to that open vehicle to grid integration platform, is that we be able to have interfaces to allow service providers with their own platform, say an electric vehicle charging management system provider that provides services for customers and also wants to interface with flexibility service opportunities in the market, or non-wires alternatives for the DSO, or objectives for the community like improving resiliency. So that's an architecture that we want to be able to take advantage of. So I mentioned resiliency. I think this is a really important use case that electric vehicle charging can be an integral part of. We're already seeing in the US with the Ford F-150 truck, being set up to be able to provide local resiliency, to the household as one of its functions. And if we take electric vehicle charging infrastructure and integrate it with larger energy storage systems, especially for fleet charging, bus charging, large systems, and we implement energy storage along with the electric vehicle charging infrastructure, we can participate in many value propositions. One of those being the ability to isolate and provide local resiliency to those systems. So this smart power integration node is a concept that we've been developing at EPRI, and California is a particularly attractive place for this because of concerns like wildfires and other issues where we have resiliency problems, and we can have local solutions to provide resiliency for individual facilities, individual homes, through these issues. So resiliency, very important use case, and the electric vehicle itself with its charging system, and especially electric vehicle integrated with energy storage and renewable systems, can be a very important part of a resiliency solution. So I wanted to highlight that. So that's kind of the things that I wanted to emphasize, that there's many value propositions, and we heard that from Antonio and others. We need to integrate with markets and operations, and we need open platforms to do this. There are a lot of research activities going on in this space, but there is still a lot of coordination that's needed. Integration with energy storage can really help, and V2G can be part of that as well, as part of an overall resiliency strategy. And I think this is something that we haven't emphasized enough in terms of the potential value streams. And finally, the role of the community and the customer is absolutely critical. So education, engagement, and services that the customer can take advantage of in a very simple manner, absolutely critical. So those are the points that I wanted to highlight, and I'll turn it back over to Ravi.
Thank you. Thank you, Mark. Our next presenter is going to be Mr. Makoto Yoshida. Yoshida-san, the next 5 minutes is yours.
Thank you very much. Can you see my slide now?
Yes, we can. You can make it full screen if you want.
Yes. Okay, sorry for the different format and a bit number of the pages, but I would like to skip. So of course, this is the reason why we need a battery to buffer the energy for the carbon neutrality. The only one thing I would like to mention here is, if we select a dedicated battery just itself, it could be much costly. So battery is expensive, and also battery exhausts CO2 footprint when it will be produced. That's why we would like to recommend utilize battery on the vehicle or from the vehicle for the sustainable business viewpoint. So the benefit of V2X on the battery on the EV, we can storage the electricity to utilize the renewable energy and provide back to the electricity grid for just a load for leisure work use, and PV utilize PV generated energy, shift the peak back to the grid, especially demand side. So this EV value up. This causes EV value up, battery resale value increase, because EV can carry the electricity. So customer will enjoy the low electric fee, and the grid side also less investment for grid stability. And also, as our April guys said, emergency help like resiliency, social needs is there. So based on the carbon neutrality as a global basis, we have these 4 big benefits from the V2X technology. So we need the compatibility to the charging infrastructure, of course, between car and the chargers, but also we have to think about the compatibility with the power grid as well. Therefore, we CHAdeMO Association is trying to sustainable communication through the standardization, because we are the standardization body, as Ronike-san's OCPP or IEC, ISO, or of course CHAdeMO have tried to establish the standardization for the physical transform of the electricity energy, but communication-wise as well. Due to this kind of theory, we conduct a lot of experimental projects and commercial application globally. And also, as you can see, many of the products are already in the market. Only in Japan, unfortunately, we had a very heavy earthquake attack in 2011. After a year, we have to introduce these kind of machines or the systems into our market due to the resiliency of the energy grid. To tasks as a sustainable business scheme, I would like to emphasize in three fields: the cost, technology, and business scheme. Cost, of course, dedicated battery is expensive, so duplicate as EV, not only for battery. As you can see the graph here, huge stationary battery, home use battery, battery on EV, battery from EV. It was reused battery, repurposed battery as well. So unfortunately, V2X power conditioner system are a little bit expensive right now, so need to cost down by proper specification. So we are not focusing on the exaggerated specification for the V2X technology, but talk with the power grid side as well. So what is the requirement from power grid? So these type of requirement will cause the very beneficial and proper specification of this type of machine and the EV battery as well. Technology, the big issue is, of course, battery may deteriorate due to this kind of power transfer. So, of course, grid side as well, power grid output quality is necessary for the, unless grid stability will be deteriorate as well due to the design of V2X transform. And we believe that grid side have a responsible and, of course, right to request certain quality, because in our business scheme, grid side pay for the system and the cost for the end customer. So lastly, the business scheme, of course, establish battery eco cycle, because battery will be the most contribution body of this kind of system. So as I said, on the EV and from the EV. So from the EV system, repurposing battery or even recycling for the material saving. So this could be such kind of circulation will be conducted under the manufacturer's responsible. Manufacturer meant probably vehicle manufacturer, battery manufacturer, or repurpose manufacturer as well. So such responsible organization, industry may have a data access and information to control the quality of the battery. I do run very much quick, but I'm very happy to have your question by email or of course, after this panel discussion as well. Thank you very much.
Thank you. Thank you, Makoto-san. Our next speaker will be Professor Marc Petit. The next 5 minutes is yours, Professor.
Okay, thank you. I will share my screen. So now you should see the presentation. So thank you for the invitation. And so some words about the impact of EV users on the potential of flexibility for electric vehicle fleets. As it has been mentioned, the users are at the center of this issue of EV charging and eventually also grid services that will be delivered by EVs. And so, so this is a key point. And typically, we can consider that we are two behaviors that can be considered. First, a systematic plug-in behavior. It means that the users are plugging to charge as soon as they park, for example, at home, or maybe, if possible, at work. And the second case, what we call here a non-systematic plug-in. It means only that the users will only charge only if they need. So it will, in that case, it will depend on the state of charge of their vehicles and on the distance that they have to travel for the next trip. And I will present you some results from a PhD work, and where we have built a model for this behavior of the users. And we have started from data from a UK project, and that is the Electric Nation project. So the data are public. And so it is a 3 years data regarding the behavior of the users, and more specifically some data about the battery size, the amount of energy inside that were put at during each charging session, and at what time people charge, etc., etc. And from the data, it can be seen that roughly there are two groups of size of battery, either small size or large size of battery. Typically, for large size, it will be premium cars like Tesla, for example, and most of other electric vehicles cars are in the small battery cars. And so from this data, we have observed several things. First, we have observed that for large EV, it means EV with larger battery, there are less charging stations, and at each session, users put a larger quantity of energy, and also that large EV also have a little bit longer trip distances. And at the end, it can be observed that globally there is a large heterogeneity regarding to the behavior of the users. And here you have a small figure that was plotted from the data, where we can define some tendencies regarding to the behavior about the daily distances and the relation between the daily distances and the number of charging stations per week. And it is possible to distinguish quite clearly the case with a large battery or small battery. And from that, the idea for us was to build a model of the behavior of the user for charging. So the behavior is represented. The model here is represented in the figure, with typically depending on the parameter that is alpha. The mathematical formula is not given here, but we can represent three types of probability that we call low, average, or high probability for charging. And you can see that for high probability charging, it means that people, for example, here will more or less always charge until the state of charge is less than 60%, for example. And from this model, we made some different Monte Carlo simulations to estimate both the impact of the charging station onto the grid, and also to estimate the potential of flexibility. Here, we have focused on the peak load. So, and what we call the coincidence factor. So it means that when you have several vehicles, you have like a smoothing of the peak. It means that the peak load is not the sum of all maximum power of each vehicle connected at a given moment, or all the vehicle of a fleet. And so here we plot the average power that is in kilowatt per EV, and it can be observed in on the right, for example, that whatever the behavior for charging, so it means the systematic or non-systematic, there is no really difference regarding in the case of uncontrolled charging, if there is no control. So it means that people will charge when they arrive, when they plug it. Here, the difference is only depend on the power of the charging point. And for larger fleet, what you can see here, there is a decrease of the peak power, or the average peak power, due to a global coincidence. But if you put a price responsive, a specific price for the yes, a specific price of the charging station, for example. In that case, you will create some simultaneous behavior, and you can observe that here that you have some difference regarding to systematic or non-systematic charging. And so it means that with the systematic charging, vehicles will always connect more or less at the, start to charge at the same time. And then in that case, you have a higher peak load. And then regarding to flexibility, the first step was to estimate the flexibility. And the question was, how can we estimate the flexibility of the vehicles? And here we have used the representation on the figure on the left. And so you have you consider a vehicle that arrives and with the given energy when it parks. And you have here at this point the target value of the state of charge before departure. And in green, this is the flexible area finally, and the red lines is the trajectory you can have inside this green area, considering that if you deliver some services, it can be unidirectional or bidirectional, for example. And so from that, we can estimate the flexibility of a given fleet. And here, this is on the right, you have an example for single-phase charging point and for different size of vehicles. In the present case, it was 1,000 vehicles that were simulated. And so you can see that the storage and then the flexibility will be higher with a systematic charging behavior. And so as a conclusion, if you consider the flexibility potential for the aggregators and operator, so systematic charging will increase the flexibility of EVs and the potential of flexibilities. And so if we increase the plug-in ratio, so it will be more effective to increase the flexibility. It will be more effective to increase the plug-in ratio than to increase the battery size. Because if you increase the battery size, people will charge less, but when they will charge, they will need absolutely to charge, and then they will have less time for good services and so for flexibility. And so it means that we need to define some incentive for the user to plug in. And last point, of course, reliable fleets like company fleets probably could be better and could be more reliable assets for flexibility delivered by EVs. Thank you very much.
Thank you, Professor. Our last and final speaker in this panel session is Mr. Ki-Jun Park. Mr. Park, the next 5 minutes is yours.
Okay, I will share my slide. I hope you can see my slide. Can you see it?
Yes, that's fine.
Okay. Okay, thank you for inviting me to discuss and update progress of Korean V2G development and the demonstration project. KEPCO and Hyundai Motor Company and charger manufacturers in Korea work together to develop a V2G system using the AC and DC CCS Taiwan charging standard. To the best of my knowledge, I think this is the first commercial grade AC V2G project using CCS Taiwan plug and the ISO 15118 standard. By the way, I will introduce a little bit about the situations of electric vehicles and charging infrastructure in Korea. The Korean government set a goal to deploy 3 million electric vehicles by 2030 and 1.1 million by 2025. We are also expanding charging infrastructures So we will have about 17,000 DC fast chargers at every expressway and connection centers. That including like 400 kilowatt ultra fast chargers. Last month, the number of electric vehicles in Korea exceeded 200,000. 5 years ago, it was like only 5,700. It's like a twofold increase in 18 months. So we will see a lot of electric vehicles around next year and year after next year. This slide shows the public charging infrastructure grow in Korean Peninsula from 2017 to the June of this year. There are about 72,000 public chargers in the country. Among them, the KEPCO, we operate about 10,000. Among the 12,000 DC fast chargers, KEPCO share is about 30%. We have started a V1V smart charging demonstration project a few years ago. We have installed 100 chargers for individual customers and for KEPCO commercial electric vehicles. 61 electric vehicles of 8 KEPCO branch office and about 64 electric vehicles of individual customers are participating in the program every day. We tested about 11 different electric vehicles for this smart charging project. And all those customers always get their charge by the departure time. Now I will discuss a little bit about the V2G. As we've seen from the YouTube or car brochures, the V2G hardware and the technology is realized as a V2L function of recently introduced electric vehicles. It is begin with the Hyundai Ioniq 5 that produce 220 volts, 3.6 kilowatt of power, which is available from the electric vehicle for whatever use. No additional cost. It's a standard feature of that Ioniq 5 and EV6 and Genesis GV6T. I think the V2G ready vehicle will be commercialized sometime in 2023 or 2024 model year when the ISO 15118-20 V2G standard is finalized sometime this year or early next year. The V2G demonstration using Ioniq 5 electric vehicle will start from next month. Now we are accepting applications from individual customers who bought the Ioniq 5 EV. A 7 kilowatt AC or 20 kilowatt DC V2G chargers will be installed at customers' home, workplace, or commercial buildings. This Ioniq 5 electric vehicle will be updated with the V2G firmware at the service facilities of Hyundai Motor Company to enable the V2G functions. During the demonstration program, we will test various control functions and the real-world usability of the chargers and the discharging function. For this demonstration, we are using ISO 15118 draft protocol that published in 2020. To control this chargers and the control system, we are using a KEPCO 3.0 protocol that is enabled with the V2G and the smart charging functions. Thank you for your attention. Thank you.
Thank you, Mr. Park. Doing a time check, we seem to have 5 minutes for Q&A. because there's a 15-minute closing session that is required. So let me begin. I see a lot of questions that are very deep dive technical, which I think maybe the organizers may want to do a separate session on them. But there are some good themes that have come out. I think is the question of the capacity of the chargers. So let me pose a question to all our panelists, if you want to turn your cameras on, and with very short answers so that we can get through as many as we can. In many parts of the world, street parking is the only parking. And yet many of you have talked of home parking, fleet parking, etc. How would you address the question of parts of the Asia, downtown New York, downtown Toronto, where only parking residents have is street parking? So it would probably be an L1 or L2, or what are your thoughts? Anybody? Yeah, Antonio.
Shortly, as I was showing, there are several use cases. Of course, if you have a place where you can easily install collective access parking, like recreation center, shopping center, cinema, leisure places, hotels, working place, and houses, this will be first. The residual ones, the cars which do not have a private parking, not at home, not at work, they will need the street chargers, but this is part of the program of being developed, and we see in everywhere in the world. And this can be, since normally parking is comes with a payment. If you make a calculation, normally you pay more for the parking than for the energy you draw from that. So you could even have a business model where you pay the same parking and energy is almost for free. So it's not an infrastructure problem, not also a business model problem, but it has to be considered, because if you don't allow combustion engine cars to be sold, you must first be sure that nobody is left behind. So it's a social issue in this.
Anybody else quickly? So the next question I have is, I think about parts of Lonike's presentation and others. We have various charger cable connectors in the world, the 4 major types. We have various telecom systems in the world, major types. We have several open architectures still being talked about. How do you think all this will come together? Because in the smart meter world, it hasn't come together in the way we thought it would come. It has taken us 20 years. So what are your thoughts around how this will quickly come together? Is everything outside of power systems, but connectivity oriented? Anybody else?
Could jump in, it's Mark. I think,
Yeah.
I really think that, and we see this in the OneNet project as well, that the integration comes together in the cloud. And the important part that we need to really standardize is the information exchange requirements associated with each of the use cases so that the right information is available to exchange. But I think that with all of the different providers that there are, to think that we're going to have one, interconnection standard that everyone uses is probably not going to happen. It's going to be many different service providers, and we'll have to integrate with them in the cloud.
Okay, thank you. Yep.
As a charging infrastructure standard organization, I think this issue, the electrical grid, could be the master of the grid center cloud. Therefore, the standardization for the charging could be not, the importance is to be harmonized for the future. And how to harmonize is not to jeopardize the grid operation. That's the most important thing. And one single communication could be best, but the charging infrastructure must be flexible to combine with all type of communication system, like Wi-Fi system could be Ethernet, like a physical layer and communication layer as well. So this flexibility and how can be say, the sustainability could be the most important part, I think. Thank you.
We have just 1 minute left. Oh yeah, sorry, Lonike, yourself.
Yeah, I just want to comment that, of course, we do our best to help all markets with one standard, and the standard I'm referring to is OCPP, of course. And we try to do that by listening to the markets. So, for instance, we visited Korea last week and listening to what does Korea need specifically. also in India, of course, what it is that you need at what point in time. So we do our best, but I think also this whole new development towards electrification of transport is something that's really important for industries, also for countries. So I think maybe it's too scary, to put it like that, for everybody to put all their eggs into one basket. So maybe it's just natural that there are several options for the market to choose from, and not that everybody depends on one standard. Maybe that's just too scary for some markets. That's my thought.
One final question, and this may actually elude Reggie and Luciano for a report through the IEA. And that is, if you look at the various pieces and the actors that Antonio talked of and others talked of, you have the consumer with the vehicle, and then there are incentives for EVs. And then there are other parts of the V2G system that lies in the utility, lies with the developer. So the question I have for you is, who pays for it? Do you think it should be paid by the taxpayer because it's the good of the society? Should it be paid by the ratepayer, as some of you have just alluded to, that utilities should take that on? Or should it be private market developers? So the question is, in the end, the customer will pay, but who will pay for the initial capex? Because every announcement that I have seen in the last 1 month is not 100 chargers, it's 1,000 chargers. Today itself, India has announced 2 announcements of 3,000 chargers each. Canada, GE has announced 3,000 chargers each. So to Antonio's point, if we don't get it right now, there are questions in the end that we'll probably need to revisit it, as he puts it. So any thoughts on that?
Please, Reggie.
Reggie, you're on mute.
No, I am unmuted. Can you hear me?
Yep.
As we all know, V2G as a service has not been offered anywhere. Wherever this is being done are all pilot projects. So pilot projects, some grants, some research program, something or the other is paying for it. So only when the results of the pilots will go to regulators and policymakers, and when it will be scaled up, the question of how to incentivize those who are participating, how to pay for the initial infrastructure, those questions are yet to be answered. That is the very reason why we are bringing this topic to the attention of the top policymakers from ISGAN member countries, which are about 28 of them. So we need to work towards making it operationalized or commercialized in the next 1 to 2 years. You would have seen that 2 days ago, there was an announcement that Hertz ordered 100,000 Tesla electric vehicles. The whole announcement which you are hearing of late are big numbers, not small. And incidentally, India last 3 months, the two-wheeler market, the more electric two-wheelers have been sold than the regular two-wheelers. And it's picking up. People post-pandemic, those who were using public transport like metro, like bus, post-pandemic, they don't want to go in such public transport crowded places. They are buying two-wheeler, electric two-wheeler. And the price of fuel in India today is at $1.50 per liter of petrol, and electric transportation is 1/10 the cost of it. And incidentally, we have been advocating that for two-wheelers and three-wheelers, it should be sold with electric two-wheelers, and three-wheelers should be sold without battery. Battery should be leased from a battery leasing agency, which will. So this has already started. Last year in July, Government of India approved two-wheelers and three-wheelers can be sold without batteries. And if you recollect, Ravi sir, we started this from our Calcutta report in 2017. So that's the only category of vehicle where we can actually swap the battery. There were many questions in the chat box about battery swapping. So in a car or in a bus and all that, swapping doesn't work for a variety of reasons. And but two-wheeler and three-wheeler, it can be successfully done. And some business models are already, or startups have already started mushrooming in different Indian cities on battery leasing. And two-wheeler without a battery is half the cost. Same with three-wheeler without a battery is half the cost. The cost of entry to electric mobility is drastically coming down with that, and we will see a lot of action here. So I'll stop.
Yeah, thank you. So this alludes, in fact, to the closing session by the two of you, and for taking this subject further, Luciano, and to see where you can help with the help of other agencies, international agencies. As you know, this is unfinished business, but yet the investments are being made. And hopefully they will not be, as Antonio says, revisitation of these investments 10 years later. So over to you, Reggie and Luciano.
Yes,
Okay,
just a remark regarding to the investment. We can say that some years ago, when the market was uncertain, there was a clear question, a clear issue about the first investment. And so for that, there was the public incentive. But now, as it is clear that the electromobility market will grow, for some important actor, they're ready to take the risk, and then they begin. We can see that they begin to invest. They invest in charging point, even if they know that presently they will not earn money, but in the future maybe they hope to earn money. And their fear now is whether not to be present, and so to more or less to miss the train.
The question is very nice, and I had a very long answer. I refrain from making my answer because we are right on the time to make it to the conclusion. But I think it's food for thinking, so we have to come back on this issue and discuss all together. Thank you so much. Reggie, the floor is yours.
Ashima, can you project the slide? We have the announcement of the 8th ISGAN Award of Excellence. GSEF is honored to be again conducting the jury panel for the last 7 awards. We had the honor of giving the jury panel to evaluate the entries. This time again, ISGAN has given that responsibility to shoulder to us, and we will be announcing the theme for the panel. So Ashima, can you please project the next slide? Yeah, this time we have 2 awards. One is rightly the same topic which we are talking about, EV integration in smart grid. That's the main technical theme. And the other one, which Luciana will talk about it, we need a skilled workforce for managing the smart grid. As we heard in the presentation and in the webinar panel, EVs are becoming an integral part of the grid. And 2-3 reasons why vehicle manufacturers are now interested in offering this as a service, which they were not so far. One, as the price of the battery has come down, at the same time, the performance of the batteries has gone up drastically high. And in many of the new generation of the EVs, which will be launched in 2022-23, the batteries might outlive the EV itself. That's a prediction. So earlier, but the vehicle manufacturers were afraid of offering V2G as a service. If 10 times, 20 times every day people charge and discharge, then the warranty of the battery, which came from a battery manufacturer, which was limited to 2000, 3000 cycle, that would have been over in a year. They didn't want to pass on that. But now with the new battery chemistries and the battery performance improvement, vehicle manufacturers have the confidence to offer that, which in Mr. Park presentation you have seen. Hyundai is offering already V2X. You can take power for any application from the vehicle, and this is going to be a regular feature in the new vehicles which you will see in 22, 23, 24. All vehicle manufacturers will make it as a standard feature. And with that, and millions of these vehicles which are connected to the grid, if we are able to aggregate them as virtual power plant, that will be the dream for the grid operators with the increasing level of variable, intermittent, renewable energy sources connected to the grid. So this theme is open for, this competition is open for not only the past, most of the competitions were open only for the utilities, but this time it can be for charging station operators, it can be for research laboratories and universities who have conducted V2G experiments, it can be for fleet operators and transport companies, etc. This is open to all, and ISGAN will be soon announcing this competition. But we have we are taking advantage of this platform to present this. So we would expect the participants to have at least 3-4 of the functionalities which you are talking about successfully demonstrated. That is smart charging of the EVs, vehicle to grid or vehicle to building technologies, or vehicle to grid services, offering ancillary services to the grid. Many places it has been successfully demonstrated. Same, the virtual power plant operation and EV charging with renewable energy, and also rooftop PV integration with EV charging stations, so that the intermittency of the PV output can be smoothened by the batteries. So these are a couple of functionalities which we have finalized with ISGAN in the announcement, which will be the rules of the competition, which will be announced very soon. And the competition is open till January 2022. These are the dates. 8th November onwards, it will be nomination opens, and around 22nd January or something, the last date for submission of the 21 January, last date of submission of the applications. And the award, as in the past, will be announced by early March, and it will be conferred to the winners at the 13th Clean Energy Ministerial function. Thank you. I stop here and give the floor to Mr. Luciano for the other award. Over to you, sir.
Thank you very much, Reggie. I will just add that this is the first time that ISGAN and GSEF are going through this dual approach with 2 awards to be made in parallel. So we will have 2 distinct jury. We will have 2 distinct request and application for project to be evaluated, and we will assign the award to the best one. If we go back 1 slide, I will just say a few words about the second award that is a kind of new, because as ISGAN and GSEF, we always addressed in the past some technical issue and collected best-in-class project around the world on technical matter, installation, project, demos. In this case, we address something that is more related to the societal aspect, and maybe you agree with us that to achieve a carbon neutrality by 2050 is requiring more than increasing our ambition just in green infrastructure and green society. We really require the new workforce that has the appropriate skills and capable of delivering on the clean energy transition. And I would like to recall you that in this year, Canada, US, and the European Commission launched a new clean energy ministerial initiative with the title Empowering People, Advancing Skill and Inclusivity for a Just Clean Energy Transition. So this initiative seeks to highlight the importance of socioeconomic aspect and element in our energy transition, and also everything that is related to empowering people, because all this transition will be at the end beneficial for the consumer, to all of us. And the Empowering People initiative will be working with the other SEM initiative all together. And this award is the first example that is opening to our SEM work stream as ISGAN to make a joint award on projects that need to be submitted on this specific aspect that related to equity, workforce, capacity building, importance of creating a new generation of engineering, of people that can address the challenges of energy transition, also taking into account the major effect on the environment, on the people, life, on everyone in the end. So this is why we supported 2 different awards. It will be double work, it will be double effort, but we know that is the best way to work. And on top of that, we will gain also additional visibility because at the next SEM 13 that will be hosted by US in autumn next year, we will have also the opportunity to showcase this new award and to have a dedicated space to announce the winner together with the winner for AV integration part. So it's a win-win situation, and we hope everybody will be interested to submit a project in order for have a large variety of projects to be scrutinized and to be evaluated. Thank you very much for your attention, and back to you, Reggie, for your final remarks.
Yeah, before that, I would like to thank Mr. Ravi Sitapati for moderating the session so well, and to all our eminent panelists for sharing their expertise and knowledge with us. Requesting all the audience to kindly cast their vote for the questions showing here. Let us know. Yeah, Parul, can you please share your screen? Thank you. Requesting all the audience to kindly cast their vote for the questions showing here. Let us know your feedback, and the link has been posted in the chat box. I would like to invite Mr. Luciano for the closing remarks now.
Okay, thank you very much, Ashima. Thank you to all GSEF colleagues and also ISGAN colleagues that contributed to this event. This event would not be possible without the distinguished speakers that share their knowledge, share their information, and make this webinar, to me, very interesting and fruitful. I think sharing information from different parts of the world help us also to shape the strategy for the near future. In this case, you know, electromobility and the electrification of transport is a very important aspect and need to be properly addressed in order not to become an additional challenge to our existing power system, but to become an opportunity to provide additional flexibility to the system in order to accommodate even higher share of renewables. This will also accomplish us to reach a very decarbonized system in a short time. You know that many countries already committed for a net zero energy system by 2050. There is a long track of activity ongoing. Nevertheless, we have to act fast this decade in order to be able to reach the ambitious goal of net zero by 2050. So this is an opportunity. We want to really deal with all R&I aspects and will make this a great opportunity for our system. Thank you very much for being with us for this webinar. We will have a follow-up. I think all the material will be shared with all participants, and we will be listening to your comment in order to organize a follow-up webinar in the near time. Thank you. Reggie, maybe you want to say a few words before we close the webinar. Thank you.
Thank you. We request all the speakers to switch on their camera for a group photo.
Very good idea.
And the webinar is recorded. The link will be available both in GSEF website as well as in ISGAN website in the next few days. Sneha, please take the pictures. And we will be mailing to, there are more than 400 people registered for the program. All the registered participants will receive the link along for the recorded session, as well as all the PPTs will be available. And we will also send a mailer to all the registered participants in the next 2 days. Thank you very much to all the distinguished speakers who contributed for this webinar, which is very successful. More than 170 people participated in most of the time. And thank ISGAN, particularly Luciano and his colleagues, Skyzone and Chloe Song-Chi-Yun from the ISGAN Secretariat for making it, for their untiring efforts, and also thank my colleagues from ISGF, Ashima, Sneha, and Videshwari, who have been working hard for this, and all the participants from around the world. We have a truly global audience who participated, being standing till end. We almost on time, and special thanks to Ravi Sidabadi sir for moderating the session very brilliantly. We almost on time, only 3 minutes we have exceeded. So look forward to seeing you all in a physical event very soon, God permitting. All the best, stay safe, good night, good afternoon, good morning, all the participants. Bye.
So
Bye-bye.
thanks.
Thank you, Reggie, for making this possible.
Thank you, everyone. With this, we come to the end of the webinar. I would like to thank all the eminent speakers and panelists for sharing their experience and knowledge with us, and all the participants for joining us for this webinar. Have a good evening and stay safe. Thank you.
Thank you to you. Have a nice evening. Bye-bye.